This lesson is on how to prove the quadratic formula, which states if ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course this only works when a is not equal to 0. So a perfect square of the form 2a rests on rewriting the left-hand side so that it contains a perfect square. In other words, we want to get something of the form x plus y quantity squared is equal to stuff. And the stuff will be some numbers. And that is, we want to find y in terms of a, b, and c. And here you can see I've identified we want to find the y up at the top in terms of the a, b, and c in the equation. To start, we suppose that ax squared plus bx plus c equals 0. Or for example, we'll let 3x squared minus 5x plus 7 equals 0. You can see on the left we have the general case, and on the right we have a specific case. In both cases, we're going to solve for x. So I'm going to be doing both of these cases together, starting with the specific case and then using that to help understand what's going on in the general case. So the next thing we do is we divide both sides by 3, or on the left side we divide both sides of the equation by a. On the right we get x squared minus 5 over 3x plus 7 thirds equals 0, and on the left we get x squared plus b over ax plus c over a equals 0. On the right we subtract 7 thirds from both sides to get this equation, and on the left we subtract c over a from both sides to get this equation. Now this is the coefficient in front of the x. That's sort of our magic number. We're going to take that number, in this case minus 5 thirds, and we're going to half it and square it. So that's the same as multiplying by a half and then raising it to the power of 2. When we do that, we get negative 5/6 squared, or in this case 25 over 36. We put that negative 5/6 squared over on the left here, and we're adding the same quantity on the equation to the right, but we're going to write the numbers differently. It's going to serve our purposes later if we write them in these forms as I've shown. Now, the left-hand side of the equation is a perfect square. It's of the form x squared plus 2yx plus y squared. This isn't necessarily that obvious, but if you look closely, you can see that y is equal to negative 5/6. So, in the general case, what we did is we took the b over a and we halved it and squared it. We wrote it in the factored form of b over 2a quantity squared when we added it to the left-hand side of the equation, and we used it in the multiplied out form b squared over 4a squared when we added it to the right-hand side of the equation. This implies that x plus b over 2a quantity squared is equal to negative c times 4a over 4a squared plus b squared over 4a squared. So again, you can see on the right we're just finding that common denominator of our two fractions, in this case 4a squared. Now what we want to do is we want to solve for x. So on the right hand side we get x minus 5/6 squared is equal to plus or minus the square root of negative 84 plus 25 over 36. And then when we take the square root of a square, we just get x minus 5/6 is equal to plus or minus the square root of 59 over 6. And then adding 5/6 to both sides, we get x equals 5/6 plus or minus the square root of 59 over 6. In the general case, we take x plus 2b, and that's going to be equal to plus or minus the square root of b squared minus 4ac all over 4a squared, right? We just took the square roots of both sides of the equation above. Now subtracting b over 2a from both sides gives us this, and then simplifying the radical and finding a common denominator gives us x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, or the quadratic formula. Now let's check it by what we did on the right. So negative b is equal to 5. Good. b squared minus 4ac is equal to 5 squared minus 4 times 3 times 7, which is 25 minus 84, which is a negative 59. So here I can see I dropped my negative sign, and I'll put that back in. So that one checks. And then lastly, 2a is equal to 6, and that checks, and that's the end of the proof.